What's up guys, it's LeetCoder. This is LeetCode 19, remove nth node from end of list. We're given a linked list like this one, and we have to remove the nth node from the end of the list, and then return the list's head. Okay, we want to remove 4 here, and so n is 2, as in the second element from the end of the list. And let's think of the easiest way of doing this. Well, it would be to go through the list once, get the size of the list. So in this case, size would be equal to 5, and go through it again. And once the pointer reaches the size minus n minus 1, so in this case it'd be 5 minus 2 minus 1, basically the element before the element we want to remove. So in this case here, once we reach this element, we simply set its next to equal its next next. So next equals its next next. So this is equal to this pointer. Okay, but this is going through the list twice. How do we do this in one pass? Now, the easiest way to do it in one pass is to go through the linked list and store every node into an array. So now we've gone through the entire linked list, we've stored every single node into an array, and now it's very easy to get the element that we want and simply set its next to next next. Again, we do the size of the array, which is 5, minus n, which is 2, so that's going to give us 3, but we want to subtract 1 to get the actual index. And now we get this right here, this element, and we just set its next to be next next. So again, it would be something like this. But this uses an extra array when we don't need to use an extra array. Our space complexity is O of n, and we can actually get it down to O of 1. The thing to think about for problems like these, where you want to get to O of 1 space complexity, and it's a linked list, or maybe a string, or maybe an array, is think about having 2 pointers. Now in this case, it doesn't make sense to have a pointer here and a pointer here, because we can't go backwards in the linked list. It's a singly linked list, so we can't go backwards. But for linked list problems, you can have a fast pointer and a slow pointer. Now let me explain what that means. So our fast pointer is going to iterate n times. So in this case, 2. So we iterate once, then we iterate again, and now our fast pointer is done. Okay, now let's go and do our slow pointer. This is our slow pointer here. Now we iterate both until the fast pointer reaches the end of the list. So let's iterate. Fast is here, slow is here, fast is here, slow is here. And now that fast is at the end of the linked list, we're done iterating. And look at that. Our slow pointer is actually exactly where we need. It's right before the element we want to remove. Now again, we just do the simple next equals next next. So we just say that. And that's it. And this always works, because when you move the fast pointer n times, the distance between the fast pointer and the end is the same as the distance from the beginning of the list to n from the end of the list. And so doing it this way, we get an O of n time complexity and an O of 1 space complexity. And we do it in one pass. So it's even faster than the previous method that we did, where it was O of 2n really, that reduces down to O of n. If you found this helpful so far, please give a like and a subscribe, because it really helps the YouTube algorithm. With that said, let's get to the code. First, we define our fast pointer, just equals head. Now we iterate the fast pointer n times. So we say for I in range n, fast equals fast.next. Now we define our slow pointer, and while fast.next is there, we keep iterating. So in other words, if it hasn't reached the end of the list, we keep iterating. So fast equals fast.next, slow equals slow.next. Once we're done with this loop, we've reached the end of the list, and we know that slow is equal to the element before the element we want to remove. So now all we have to do is say slow.next equals slow.next.next. And then we simply return head. Now there is one edge case we need to think about. And that edge case is, what if fast here is none? Well, this is going to just error out immediately. So we have to do a check here. So we check if not fast, we return head.next. And what this is saying is if fast is not defined, that means fast is actually at the not even at the end of the list, past the end of the list, and therefore slow would actually have to be before the beginning of the list. In other words, we basically just skip the first element and we return head.next. And that's it. Our first solution was simple. It was to go through the list twice. Then we decided, okay, we can reduce going through the list twice using some space complexity. Then we said, okay, well, we want to avoid using space complexity. And that's where we had to think about using 2 pointers. And once we figured out, okay, we need to use 2 pointers, then we had to be a little clever about the spacing between the end of the list and the beginning of the list. And also the spacing of where the element we want to remove is. And so that's kind of the intuition of how to approach this problem. And that's it. So let me know down in the comments if there's any problem you'd like to see next, and make sure to hit that like and subscribe button. See you next time.